In this example, we are going to try to find some absolute maxes and mins on the following functions. So because we have an interval, let's go back for a second. We have an extreme value theorem. So because we have an interval, it's a guarantee that we will have, as long as it's continuous, an absolute maximum and an absolute minimum. Guarantee. So we have an interval. And x to the fourth is going to be a continuous function. And so we are definitely going to have a high point and a low point. It could be the endpoints that are the absolute maxes and mins, or it could be some points in between. We don't know. That's what the math is going to tell us. All right, so to do that, find our critical points, we're going to be taking the derivative and setting it equal to 0. So we're going to do the derivative of this, set it equal to 0. So I have f prime of x is going to be 4x to the third minus 6x squared. And then I'll take that and set it equal to 0. So 4x to the third minus 6x squared equals 0. And I'm going to solve that. So to solve that, I'm going to take an x squared. I'm going to take a 2x squared out. And I'll be left with a 2x minus 3 equal to 0. So I'll set each of those factors equal to 0. So if I set that equal to 0, I get a solution of 0. And if I set that one equal to 0, I would add 3 and divide by 2. So I get a 3 halves. All right, so those 2 points are within this interval. So I have 4 points that I need to figure out. So we're going to test the critical points. Oops. Test critical points and endpoints. Okay, so we're looking at f of -2, and then I have 0, f of 0, and then I have f of 3 halves, and then I have f of 2. Okay, so these are potential highs and lows, but I don't know if the graph levels off. All I know is for sure those 2 middle points have slopes of 0, but it could look like this, could look like this, or could look like this. I don't know. So, but all I'm looking for are the absolutes. Okay, so I'm going to dictate that or figure that out by literally just plugging this into the original equation and get the y values and figure out what's the highest y value, what's the lowest y value, right? So, and before I do that, just to kind of put all of this together into some sort of a visual, I have an x to the fourth minus 2x to the third. And I know an x to the fourth potentially could look, something like this. I have no idea, right? And we're doing an interval, which means we're doing a chunk of that. The low point could be here, could be, where it dips down lower here and not so low here. We have no idea unless I actually draw a visual to it. But this is going to help me figure that out. And because I have an interval, this thing's going to get cut off. But where does it get cut off, right? Like, does this exist or does this exist? We don't know. So when we don't have to figure that out, we're just going to take these values, plug them in, and see what we get. So I can do this by hand, or I can throw it in the calculator, but I already have them. So if I take -2 and I plug it in, I get a 32. If I plug 0 in the calculator, I get a 0. If I take 3 halves and I plug that in, I would get a -27/16. And if I take a 2 and plug it in, I'd get a 0. So out of my y values, I have a high point of a 32. So that's got to be an absolute max. And then I have a low point at 3 halves, because that's the lowest y value. So I have an absolute minimum at those values. And so that gives me my answers that I'm looking for. They were asking for what's your absolute max, what's your absolute minimum. And so these other points in between, if I actually graphed it and set it up into the calculator and only saw that interval from -2 to 2, I would see a high point at 32 and a low point, a high point of 32 at -2. And I'd see a low point of -27/16 at 3 halves. All right, so that was the first one. Next one we'll do is a little bit more challenging. It's going to take some more time and a little bit more space.